In this video, we're going to look at how to evaluate determinants using several methods here, using cofactors, properties of determinants, and the TI-84 graphing calculator. So let's look at the first one here. Start off with a 2x2, 2 rows, 2 columns. And basically this is pretty straightforward. The procedure is to cross multiply here. -1 multiplied by 3. So these components this way. And then we subtract the cross product the other way. So it's -5 times 2. So this of course is a -3 here, this product. And this is -10. 2 times the -5 is -10, but the minus here makes it a +10. And this of course gives me 7. And of course, one of the main applications of determinants is to solve systems of equations using Cramer's rule. I've done at least one video regarding that. So the answer to this one is 7. But before we go to the next one, I want to emphasize, look at properties. So notice what happens here. Let's say I multiply the first column by 2. And add those components to the second column. Okay, so 2 times a -1 is a -2, and a -5 is a -7. And then 2 times 2 is 4, added to 3 is 7. Okay, so I get it still a 2 by 2. So if I evaluate this using the same procedure, cross multiply, so 7 times -1 is -7. And then I subtract the other product. 2 times a -7 is a -14. Double negative here, so that makes it a +14. 14 and a -7 is 7. Which is the same answer I got by not doing anything and just doing the procedure, cross multiplying and subtracting. Now that's going to work, and that's actually one of your properties of determinants. That tells you that if you have any determinant, whether it, and this works for all dimensions, 2 by 2, a 3 by 3, 4 by 4, and so on. If you take a multiple of one row and add it to another row, any row, and evaluate the determinant, the value of the determinant does not change. This also works with, like I said, in this case I did it with the columns, but it works with rows and columns. And that's one of the properties of determinants that we're going to be using later on. I also want to point out that notice, if I take a determinant, say the first row is all zeros, and then this is, say the second row is 7 and 3. I follow the rule, cross multiply 0 times 3 is 0, 7 times 0 is 0, 0 minus 0 is 0. And that's another property of determinants. It tells you if you have a determinant where all zeros, with all zeros in one row or a column, the answer is always going to be 0. That's another property of determinant. Let's go to the next one. Okay, here I have a 3 by 3. Okay, now here we're going to use the method of expansion. Okay, so this means that we take any row, so you can do it. You can pick the first row, second row, third row, or you can use any column. First column, second column, third column. So right there's 6 ways alone to solve the problem. So what you're going to do, pick a row or a column. So here's the way it works. Let me set this one up. You're going to take let's say the first row. And you're going to multiply by what is called the cofactor. The way you find the cofactor is you eliminate the row and the column that number is in, and whatever's left is called your minor. So it's a determinant, make it a 5, a 2 by 2, so 5, -2, 3, 7. All you want to do here now is get the cofactor. Well, the cofactor is basically the same determinant multiplied by either a 1 or a -1. Now what you multiply by depends on the position of the number. So the first, the number 1 here that you're multiplying by is in the first row and first column. So you add those up. first row 1, first column 1, so that's 1 and 1 is 2. So if it's an even, this is multiplied by a plus 1. If it's odd, it's multiplied by a negative 1. Okay, so this is what we get here. Then we go to the next one. So the next one is a negative 1. So go to the next entry, and you take the row away and the column away. So let me erase this here. So this one's a negative 1. We're going along the first row. Take away the row that number's in and the column, and whatever's left is going to give you what is called the minor. So let's just put a 3 here, a negative 2 here, a 2, and a 7. And then this is multiplied by either a 1 or a negative 1 depending on the position. Well, notice here the negative 1 is in the first row, second column. So 1 and 2 is odd. So this is multiplied by a negative 1. So this sign right there is going to change. So this will be a negative 1. And then we go to the next one. So let me clear this again here. The next one is 3. So 3 is going to be multiplied by its cofactor, but first we find what is called the minor. So again, to find the minor, actually going to be the cofactor, but first we need the minor. So eliminate the row that the 3 is in, eliminate the column. Whatever's left is going to be your minor, which is the components, so 2 by 2. So this will be 3, 5, 2, 3. And then that gets multiplied out here, which means the 3 gets multiplied just like over here. So that 3 is in the first row, third column. But 1 and 3 is 4, that's even. So this gets multiplied by a positive. So this stays the way it is. And then you simply evaluate these out. Evaluate these out. Okay, it's a 2 by 2, so what do we do here? We cross multiply here. So this will give us a 35. 7 times 5. And then here, multiply here. This minus 2 times 3, that's a minus 6. But then you're subtracting that, so this becomes a plus 6. Okay, so 35 and 6 is 41 times 1, so that's 41. And then we add the next one. So this is negative times a negative. Those becomes positive. So here we just go cross multiply 2 by 2. So it's 21. 3 times 7. And then a minus. Negative 2 times 2. That's the negative 4. And you're subtracting that. So that becomes a plus. So that's plus 25. So we're adding here. And then on the final one here, we're adding whatever this comes out to be. Okay, so this is going to be cross multiply. It's 2 by 2, so this will be 9. Minus a product of 2 and 5, that's 10. That's a negative 1. And negative 1 times 3 is a negative 3. So what do we get? We get 41. Then you add these up. So it's 41 and 25 is 66 minus 3. This becomes a 63. That's the answer. So this is using the expansion method. It tells you that if you have a determinant, you want to evaluate it. The 2 by 2, no problem. It's just cross multiplying and subtracting. But if you have a 3 by 3 or a 4 by 4 or a 5 by 5, you pick a row or you pick a column, whatever you want to do there. And then you find the cofactor of each component of that row or column, multiply those values, and then you add. The sum of those 3 products is going to give you the value of the determinant. Because you're multiplying the cofactor times the number of in the individual rows or columns, you want to use the row or column that has the most zeros. Cancel this out. And let's go to the next one. So here's one. I'm evaluating this 3 by 3 determinant. I can choose any row or column. So I'm going to use the expansion method. Okay, I'm going to use the expansion method. So obviously I want to pick the second column because that has the most zeros. The way this would work then is I would simply take the 5 multiplied by the cofactor, the 0 multiplied by its cofactor, the next entry is also a 0, multiply it by its cofactor, add those up, and that's the answer. Okay, so obviously I only have to do the first one because 0 times anything is 0. So I use the 5 here. Okay, eliminate the row, eliminate the column that 5 is in, and what's left? It's 11, 7, 2, and 2. And then the only thing you have to determine is, does this get multiplied by a 1 or a negative 1? So again, it depends on the position of the 5. Well, the 5 is in the first row, second column. That's odd. So this becomes a negative 1. And obviously the next one I don't have to do, like in the previous one, because 0 times the cofactor, it's going to be 0. So for this one, then it's just going to be negative 5. Then 2 times 11, this is a 2 by 2, you cross multiply, so this is 22. And then cross multiply here, this is minus 14. So then you just multiply these two products. So we have negative 5, 22 minus 14, is 8, I just say here. And then negative 5 times 8 is minus 40. So that's the value that we have. Now this method works out pretty good if you're taking a test and the instructor doesn't let you use a calculator and you have to do this manually. There's a lot of calculations if you don't create the zeros. So you always want to create zeros in a row or a column. So all you got to do is, the easiest way to do it is pick a row or a column that has at least one number with a 1 in it, one entry with a 1, and then do the same thing that I'm going to do now. So let's clear this. So go back to this one right here. Let's say I wanted to evaluate this, and I wasn't allowed to use a calculator. Then I would pick a row or a column with one entry being a 1 at least. So I'm going to pick the first, I could pick the first row here and use that. I could pick the first column that has a 1. You want a 1 or a negative 1. I could also pick the second column because it has a negative 1. But I'm going to pick the first column with a 1 right there. And then I'm going to say, okay, I want this entry to the right to be a 0. So 1 and negative 1 cancel. There I can just add. So remember, you're allowed to add a multiple of a row or a column to another corresponding row or column. So 1 and negative 1 gives me 0. 3 and 5 give me 8. I'm just adding, basically I'm just adding the first, the entries in the first column to the second column. And then 2 and 3 is 5. Now I want the 3 here on the far right here in that first row to be a 0. So there, multiplied by negative 3. Negative 3 times 1 is a negative 3. Add it to 3 will give me 0. Okay, so let's do this. Negative 3 multiplying the first column by negative 3, adding to this third column. And then negative 3 times 3 is a negative 9. And negative 2 is a negative 11. Negative 3 times 2 is a negative 6, and 7 is 1. So now I got the zeros there, so now I can expand this using cofactors. Basically have the two zeros, so this would just be, okay, using the rows of the elements or the entries of the first row, it would be 1, and then take away the row and the column, and then what's left times a 1 or a negative 1 is the cofactor. Since the other ones are 0, we don't have to evaluate those, because 0 times anything is going to be 0. So it's 8, negative 1, 5, and 1. And again, because the 1 is in the first row, first column, that's even, 1 and 1. It stays a positive here, multiplied by positive, so now we just cross multiply here. So this is going to be 1 times multiplication here, cross multiply, that's going to be 8. Okay, minus, and then 5 times negative 11 is negative 55. That's because of the double negative, that makes it a plus. So we get 8 plus 55, which of course gives me 63, which is the same thing we got using the regular expansion method without the zeros. So think about it. If you have a 4x4 and you do the expansion method using cofactors, then you're going to break it down, and each cofactor is going to be a 3x3. So you can see how that's going to be tedious. Or you have a 5x5, and you can't use a calculator. You break that down, and your cofactors are going to be 4x4s. So these can get pretty long, depending on what your instructor allows you to use. Clear this. This, of course, is going to suggest that if you have, let's say you have something like this. Let's say you're toward the end of class and the instructor tells you, give me the answer to this problem. So you're toward the end of class, maybe 5 minutes to go, and your instructor tells you, this is a quiz now. I want you to evaluate this using any method, any property you want. You cannot use a calculator, graphing calculator in particular. What is the answer? Well, some of the properties that we've had allows you to add multiples of one row to another row, multiples of one column to another column. If a row or column has all zeros, the answer is going to be 0. The value to this is 0. So notice here, row 1 and row 2. I'm sorry, row 1 and row 4 are multiples. So if I multiply the first row by -2 and add to the fourth row, all the components of the fourth row are going to be 0. So the value of the determinant is 0 because of that reason. That's going to suggest to you that if you have any determinant where one row is a multiple of another one, or one column is a multiple of another column, the answer to the determinant is always going to be 0 because of the property that tells you that you can add a multiple of one row to another row, or a multiple of one column to another column. So that's a shortcut that you should know. So those are methods that you can use, cofactors, using properties of determinants. And there's a few other properties that you can use in more advanced situations. The only thing I want to do now, and I think I've done this before with a graphing calculator, but let's go ahead and do this. Let's evaluate determinant number 2. A couple of ways you can do it. You can do it on the screen. You don't have to do it this way, but I'm going to do it this way just to show you this method. And add it here. So I'm going to do with A, and then it's 3 by 3. So remember, determinant basically is defined as a number associated with a square matrix. So we can put these components in terms of a matrix. So this is going to be a 3 by 3. So 3, enter, 3, enter, and then enter the components. So I'm going to do number 2 using the calculator. So components are the first row 1, hit enter, -1, hit enter, and 3, hit enter. I go to the second row, I have a 3, enter, 5, enter, -2, enter. And third row, 2, enter, 3, enter, and 7, enter. Now we can close this and go back to the matrix menu. And I want math and I want determinant. That's number 1. So hit enter. And then I go back to the matrix menu. Matrix A. I want the determinant of this. Hit enter. And 63. Same thing. We got using the expansion method with the cofactors. I'll show you also that you can do this on the home screen here. So all you gotta do is go to matrix, math, and I want the determinant, hit 1. Okay, instead of defining this as a matrix, I can just enter it another way using brackets. So I go to the brackets over here, one bracket, another bracket, and then basically I enter the components of each row within the brackets, within 2 brackets. So here it's 1, then a comma, minus 1, and a comma, and 2. We close the brackets. And then we enter the next one. So another bracket to the left here. Enter the 2 or 3. Comma. 5. Comma. 2. Close bracket. Close bracket. And then finally the third bracket. Bracket. Enter the 2, comma, 3, comma, 7, close bracket, then close final bracket. Close parentheses there, hit enter, and we get 60. You can see it puts it in the form of a determinant matrix there that calculates it. Okay, thanks for watching. We'll see you next time.